We've learned about mole and the mole concept and how many we have in each mole. We also learned about how many atoms we have in one molecule. So now we are going to talk about percent composition. So in the previous video we talked about uh, how many atoms. So that was like a number composition. So if you want to have a number percent composition, that would be, for example, if you have um, H2O, we have two hydrogen and one oxygen. If it was percentage of number, we had 66.6% hydrogen and 33.3% oxygen by number. But in chemistry, we use mass percent. We know that hydrogen has not that much mass. It has just 1 AMU, 1.008 AMU, where oxygen has almost 16 AMU. So it's heavier. So even though we have one oxygen but two hydrogen, but most of the mass of water is from oxygen. So let's see how we calculate that. So what is the mass percent composition? The percent by mass of each element in a compound, okay? And if you want to get a percentage of anything, it's the mass of that thing over the total mass of the compound, or the total, okay? So in chemistry, it's the same thing. It's just common sense. So percent composition of element is the molar mass. So how do we find the mass of an atom? Is the molar mass of that atom. We know that the mass of oxygen, for example, is 16. The molar mass of oxygen is 16. The atomic mass of oxygen is 16. So if you want to find the mass of that specific element, that's the molar mass of that element. And where can you find it? It's all in the periodic table, okay? So the mass of that element, but sometimes you have more than one element in a compound. So you have to multiply the number of that element in a compound, okay? So number of that element, sorry, I keep saying compound, number of that element times the molar mass of that element divided by the molar mass of the whole compound, okay? So this N is the subscript of the element in the formula. Like if we are doing this for hydrogen, for example, in H2O, we have two hydrogens, so that would be 2 times the molar mass of hydrogen is 1.008 over the molar mass of compound, which is H2O, which is almost 18, okay? So let's do some example. So if you get the concept, I want you to take some time and find the percent composition of each element in urea, NH2CO. Okay, so let's do this together. So nitrogen, for nitrogen, we have to multiply the mass of nitrogen, which is 14.007. And how many nitrogen do we have? We have 2. So you see there is no subscript here, but there is 1 here. And this means we have 2 NH2. So basically it's like NH2, NH2CO. Okay, so just we have that twice. Okay, so how many nitrogen do we have? We have 2. And how many hydrogen do we have? We have 4 hydrogen, 2 here and 2 here. Okay, so that's the mass of nitrogen times 2, because we have 2 nitrogen. And the bottom is the molar mass of the whole compound. So we have to write all the compounds. Nitrogen times 2 plus, how many hydrogen do we have? 4. So the mass of hydrogen is 1.008 times 4 plus carbon, we have only one carbon, 12.011, plus we have only one oxygen, and oxygen is 15.999. That's multiplied by 100, okay? So if you do that, the denominator is 60.999 0.056, and the denominator is 28.014, and the answer is 46.65%. Okay, so 46.65% of the mass of urea of this molecule is nitrogen. It means if we have 100 gram of urea, we have 46.65 gram nitrogen. Okay, so let's do this for the other one. So for hydrogen, we have the mass of hydrogen 1.008 times we have 4, and since we already find the molar mass of the compound, I just write a number. So it's 60.056 times 100, and that will be 6.71%. For carbon, we have only one carbon, so it's 12.011 over 60.056 times 100. It's 20%. And if you do the same thing for oxygen, that will be 26. I just write the answer, 26.64%. Okay, so in this example, what is the percent by mass of iron in Fe2O3? So it's we know the mass of iron is 55.845, and we have 2 of that, so it's multiplied by 2 divided by the molar mass of the compound. So I have to find the molar mass of compound. We have 2 iron plus we have 3 oxygen times 3 times 100, and that is 69.94%. So therefore it's B. Okay, so we can use the percent by mass as a conversion factor. How can we do that? So look at this example. It says how many grams of iron are in 15 gram of the sample of Fe2O3. Okay, so if you use dimensional analysis, we can use that conversion factor. So always start with what is given. So we have 15 gram of Fe2O3, right? So I don't want gram of Fe2O3. Oops. I want to get rid of that, so I write it on the bottom. I want the gram of Fe. And I know from the previous slide that the percent by mass is 69.94%, okay? Which means that if I have 100 gram of Fe2O3, 94 gram of that is Fe, okay? So that's a conversion factor because these two are equal, right? So if I have 15 gram of the sample, how much of iron do I have? It's 10.49 gram of Fe. There's also another way to solve this. So if I just look at this question, if I just have this question and I don't have the percent by mass, well, there's one way you can go ahead and find a percent by mass and then use it as a conversion factor, or you can use dimensional analysis directly from here to find the mass of iron. How? So we have the mass of Fe2O3. We can go to the mole because we can relate moles with number of elements, right? So we can go to mole of Fe2O3. From there we can go to the mole of Fe. So how many Fe do we have in 1 mole of Fe2O3? We have 2, right? That's the subscript. And from mole, I can go to the mass of Fe, okay? So let's do that. So we have 15 gram, 15.0 gram of Fe2O3. So I want to get rid of the gram of Fe2O3, so gram of Fe2O3 on the bottom, and I want the mole of Fe2O3. And the molar mass of Fe2O3 is 159, and we just did it in the previous slide, so you can do it yourself. 8.7. Okay, this gram of Fe2O3 is 1 mole. Okay, so I don't want the mole of Fe2O3. I want to get rid of that. Fe2O3. I want the mole of Fe. Okay, so in 1 Fe2O3, how many Fe do we have? We have 2 Fe, right? So 1 mole of Fe2O3 have 2 moles of iron. So from mole of Fe, I want to go to the gram of Fe. So mole of Fe to gram of Fe. So 1 mole of Fe is 55.845 gram of Fe, and you can see that in the periodic table. You can find it in the periodic table. Okay, so and that's what I need. So if I get rid of gram of Fe2O3 with gram, mole of Fe2O3 with the mole of Fe with mole of Fe, and I end up with gram of Fe, and that's what we want, the grams of iron. Okay, and if you put these numbers in your calculator, you get the same result. So it's 10.49 gram of Fe. So that's another way. So if you have in a question, if they gave you the percent by mass, you can use it as a conversion factor and find the mass of each element. If you don't have it, it's easier to just go straight from that mass with dimensional analysis with a couple of conversion factor to find the mass of that element.